Muted.
And let me repeat that for now that we got the recording started. Welcome to Fire on the Fives for the April 5th, 2017 edition. Go through some logistical things here. Let's see. We would please ensure that you mute your phone. Do not put the phone on hold, or else we will get your hold music. If you did not enter your audio pin at the beginning of this webinar, I would ask that you do so that we can control if phones are muted on our control panel here for the webinar. I am resending those pins to those that show that they have not entered the pin numbers. And you should be getting those, and if you could please enter your pin number, it would be much appreciated. Again, please do not put your phone on hold, or we will wind up getting your hold music, but you can put your phones on mute. These talks will be recorded, and currently they're going to be posted at the Weather Service Fire Weather Google sites at the URL that is shown here. I would also, I'm going to also try and get it posted to a site where it will be available to folks outside of NOAA. Once I get that done, I will send out word on where that will be, so stay tuned for that. Right now I have everybody that I'm able to, I have them unmuted. I'm going to leave it up to Todd, and let me introduce our speaker first here. Our speaker for today is Todd Lindley. He's from the National Weather Service in Norman, Oklahoma. He is the Science and Operations Officer, and he will be giving a talk on wildland detection notifications in Oklahoma using the GOES Rapid Scan satellite imagery. Todd, as I turn it over to you, would you you want to take questions as they come, or would you rather have questions hold off until the end of the talk? Wondering if Todd's one of the people I can't see. There we go. Todd, are you there?
All right. I'm here now,
hey,
Larry.
Much better. Okay. All right.
Good. No, we can take questions as we go. It can be fairly informal, and people can feel free to interrupt me if they have a question on a particular slide, and then I'll ask questions at the end as well.
Okay. That being the case, again, I have unmuted everybody. If you would be kind enough to put your phone on mute, and if you have a question, then unmute your phone and go ahead and ask Todd your question. But with that, I will turn it over to Todd, and take it away.
Okay, Larry, can you see my screen?
I can.
Okay, very good. Well, I just want to thank Larry and Michelle for inviting me to talk about some of the work we're doing here at WFO Norman. And like Larry said, today's topic will be about wildfire detection notifications that we are providing from WFO Norman, and these are also being provided at WFO Tulsa and in Amarillo as well currently for incident decision support services in Oklahoma using mostly satellite imagery. So I want to acknowledge a lot of the contributors. It's taken a lot of people to get this program up and running. A lot of our folks here in the office, Vivek Mahali, Aaron Anderson, our ITO, who is the author of the app that we're using. Folks at Oklahoma Forestry have been heavily involved in this, Mark Goler, Drew Daly. Also at Oklahoma Department of Emergency Management, Daniel Piltz and Zach Stanford. And we've also had some contributions from the Operations Proving Ground with Chad Gravale up there in Kansas City. So this will be a review for most of the meteorologists that are on the call, but for folks that have not had any remote sensing training, and maybe some of it may be new. But the GOES satellites have different channels or different wavelength bands that they operate in. Each channel basically remotely senses various surface and atmospheric phenomena, and they're all sensitive to various temperatures. And the shortwave IR band, 3.9 micron imagery, that has a very high sensitivity to changes in temperature and allows it to see even these sub-pixel hotspots that are very useful for detecting wildland fire, and that's been highly noted in a lot of publications throughout the last several decades. And you can see this example from northwest Oklahoma of the Buffalo Fire, which became an 18,000 acre fire back in February of 2016. And just the Planck curve there for the different wavelengths. You can see how sensitive the 3.9 micron band is, around 700K or so, which is about even a little warmer than a lot of our fires, but in that general range of a wildland fire. So to tell this story, we have to start back about a little over a year ago, back in February of 2016. And many of you may remember the Ghost 14 was occasionally operating in what was called super rapid scan operations. That was in preparation for the launch of the GOES-R satellites, which we're just now starting to beta test and use a little bit in operations. But as part of this experiment, Ghost 14 was providing 1 minute temporal resolution data during certain experimental windows, and the whole purpose of that was for the algorithm developers and the folks working on preparing systems for GOES-R could write algorithms basically in scripts to accommodate the GOES-R data, which is much higher resolution. So we actually had a period of enhanced fire weather here in Oklahoma and on the southern Great Plains. On February 18th of 2016, SPC had its outlook for an extremely critical risk of fire weather across much of the southern Great Plains. So our GOES-R liaison, Bill Lyons, over at the Storm Prediction Center, helped us to ensure that we had the access to the shortwave IR imagery for that particular event in operation. So we also requested rapid scan operations for Ghost 13. So we had platforms providing satellite imagery, of course, the experimental 1 minute data and also the 5 minute update. And sure enough, the extremely critical outlook from SPC panned out as expected, and we had an outbreak of about 71 fires, 72 fires across the state of Oklahoma that day. Some of them were very damaging, lost a couple hundred structures. This was probably the largest fire of the day, the Buffalo Fire up in Harper County in northwest Oklahoma. And this is just a comparison of the legacy Ghost 15, Ghost 14, and Ghost 13 temporal resolution. Of course, this is not the increased spatial resolution that we see with GOES-R, just simply the SRSOR. But as you can see, the progression here, just taking legacy satellite imagery and increasing the temporal resolution to 1 minute results in much finer detail of a wildland fire. And not only that, but what's vitally important here is the latency of this data coming in operationally to AWIPS. And you can see the Ghost 15 minute update. That fire became visible to our forecasters at 2112 UTC. But using the 1 minute data from Ghost 14, the SRSOR data, that fire was actually visible at 2049. Using our more traditional rapid scan operations that we use during some critical weather periods, providing 5 minute updates, that fire became visible in AWIPS in the ops area here at WFO Norman at 2057. So there's actually an 8 minute lag even with the rapid scan operations that we're more accustomed to, and then your traditional legacy Ghost 15 minute coverage latency was as much as 23 minutes. So when you're talking about wind-driven fires in the grasslands of the plains, that's a considerable amount of time and a considerable advantage using the 1 minute data. And of course, that's excluding the up-and-coming Ghost 16 data. So some more background. Of course, GOES-R/16 was launched on 19 November of 2016, several months after this fire event here in the southern Great Plains. And what it has to offer is much faster temporal updates. On average, we'll see 5 minute versus 15 minute data, but also it's capable of providing mesoscale sectors of coverage of 1 minute. And if those mesoscale sectors are actually overlapped, you can get sub 1 minute data, and we expect to see that more frequently after the launch of the subsequent GOES-S satellite here in a year or two. So, immediately the wheels start turning, and we're wondering, well, how can we utilize the faster temporal updates to really enhance our impact-based decision support services, especially in a tactical sense for wildland firefighting support. And the use of the GOES 14 SRSOR really gave us an opportunity to look forward a little bit and try to incorporate a tool in live operations during this extreme fire event on February 18th of 2016 towards that goal. So I walked in that morning knowing we were going to have a pretty high-end fire day, and my meteorologist in charge, Dave Andra, visits with me and says, with the access to this data and being the request we were getting from Oklahoma Forestry Services to let them know every time we saw a fire initiate in satellite imagery, to keep them abreast of the latest developments and how the fire situation was evolving. His suggestion to me was, well, today's the day we ought to innovate. So of course, my next step was down the hall to Aaron Anderson's office. Aaron is our ITO here. He's really one of those innovation experts that we really lean heavily on in moments like this. But like I said, the demand was coming in from the local land management agencies. They needed help seeing where these fires were developing, because they were going to be it was expected to be a very rapidly developing fire situation throughout the day. So Aaron really took the lead at stepping up into the operations area and developing this innovative Python application for use in AWIPS 2. And that's what we've been using ever since. It has gone through several iterations, but I'll go through some examples here of the tool and how it can be used. But he wrote this while the fire event was evolving, and by about 1 or 2 o'clock that afternoon, we were sending test messages to Oklahoma Forestry and Oklahoma Department of Emergency Management. So how does the tool work? In the AWIPS 2 cave environment, the meteorologist can plot points that are editable over the shortwave IR imagery. And so as soon as the meteorologist identifies that a hotspot is developing in the satellite imagery, they can identify that geolocation with a point, and then the tool basically, like I said, has gone through several iterations, and now there are several inputs that you can make for various fire weather information that you can transmit, and also the proximity observation from an Oklahoma Mesonet site. But you compile very quickly and very efficiently with these drop-down boxes and radio buttons the message that you want to send, and then from there, once you hit send, that's transmitted via a text message that's sent to a predetermined list of cellular phone contacts. And for our use here in Norman, we have it set up to go to some state-level contacts at the state capitol, including the watch officer at the EOC at the Capitol, and also to some of the agency firefighting heads at the Oklahoma Forestry. This is an example of what the text message looks like, and the message actually includes a hazard type. We're a little freeform on that, but we have some favorites that we use a lot. Wildfire, if the environment is particularly favorable for fire, and we know pretty certain that it is a wildfire. You can also just be a little more vague and put possible hotspot or hotspot. The county in which the detection was indicated, and then the fire weather category. Now this is actually a drop-down box at the forecaster input, and we use red flag threat index, which was derived by Murdoch and co-authors back in 2012. It's actually analogous to the Haynes index, but more applicable to wind-driven fires on the plains, and it's just a simple climatological ranking of the combination of RH and wind. In addition to that, we have the detection method. Was this indicated, was the fire detected with 1-minute data, 5-minute data, 15-minute data? Is there a radar smoke plume evident in addition to the hotspot? Those are the options for the detection method. And both of those last 2 bullets were added this season at the request of the state agencies. They wanted some measure of confidence that what the forecaster was identifying was actually a wildfire. And the training doesn't really exist for us to provide that. We don't have the knowledge base or the capability other than to identify a hotspot of identifying what we're actually seeing there, what's occurring on the ground. So we added the fire weather category and the detection method to provide some level of confidence for them. They know how to interrogate that and interpret that to gain some level of confidence. Additionally, the fire weather pertinent information from the nearest Oklahoma mesonet site is added, and the forecaster in the current GUI can select from a number of close proximity mesonet sites, whichever one they feel is most representative of the fire environment. And then there's a freeform area where the forecaster can add remarks. That area is actually now populating with reference from a known location. So say, in this example, 5 northwest of Moreland, and then the Latin lawn of the indicated hotspot. Now, once this text message is received, it started out, just transmitting text messages to a few, like I said, a few predetermined contacts. But at the request of the state of Oklahoma, now there's a GIS layer that is displayed along with that. And that is actually displayed on the watch officer map. It's a situational awareness display at the state capitol at the EOC there. And you can see an example of that. And we can access that also remotely online and monitor that as well. So what is some of the feedback? Well, the feedback was immediate when we first started doing this last February. And all of these statements that I've included here were received within the first few days of use of this tool from Oklahoma Forestry Service. One key contributor to a measure of effectiveness in response to very aggressive and fast-paced fire activity. The next one enabled rapid response that aided us in keeping a few of the fires small, thus reducing the threat to life and property. And that's really the key statement for us. That's our mission in the National Weather Service, is to protect life and property. And it seems that this capability really enhances that mission, allowing firefighters and boots on the ground to really engage these fires immediately without the time for them to grow and become major incidents. And then the next statement is very interesting too. Permitted contact with a few of the local departments. Again, we're going through that state agency filter, but it enabled them to call the local departments in advance of local 911 calls, even there in the local jurisdiction. We continue to use use this. Yes, sir.
This is Larry. We did get a question, and this refers back to a slide from 2 slides ago. What is the definition of fire weather level used on the little text message?
Yeah, that is actually defined as the red flag threat index from Murdoch's paper in 2012. And as I explained, that's it's a parameter that was developed for fire in the Southern Plains, analogous to Haynes, but it actually quantifies instead of looking at lapse rates and temp dew point depressions because of the wind-driven nature of our fires, it quantifies the climatological rarity or percentile rankings, if you will, of RH and wind combination. And that's how, and we produce that in GFE. We produce that as a gridded forecast, and that's how we have chosen to define that here. It is the categories are actually elevated, near critical, critical, extreme, and historic. So what we find is that index very closely mirrors the categories that you see from SPC in their fire outlooks.
Okay, thanks,
Does that answer the question? You bet. Okay. So we continue to use this tool, let's see, through the remainder of February and through March and into the conclusion of our fire season here on the Plains in April when we get our spring green up. And we had another big fire day on April 5th. And by this time, everyone's gaining confidence in this method, and the state is relaying those notifications out to the locals pretty quickly. And this was a day where in Major County, Oklahoma, we had 2 ongoing fires, and all the local resources were pretty much committed. And we had detected another fire back at their 6s further to the west in the county that they were unaware of, and the state was actually able to bring in air assets and relieve the locals of a lot of on-ground suppression efforts for that new fire, and we got praise from the local emergency manager on that one. But going back to the statement about these notifications providing the initial notice and in many cases lead time over local 911 calls, through the course of that 3-month period or 2.5-month period, that we were using this in 2016, we issued a total of 58 notifications, and 45 of those, or 78%, were actually in advance of local 911 calls. So what we're finding is that, the capabilities of the high temporal resolution satellite imagery really does have a utility of being the initial report on a lot of wildland fire, certainly here on the plains. Now, going into 2017, we formalized this process a little more, provided our forecasters more guidance on when to use it, when not, and I'll go over some of that here in a moment. But really, the first day of significant fires that we had on the Southern Great Plains this year was January 24th. And this was a quote from Drew Daly at Oklahoma Forestry: "The timeliness and location accuracy of the detected wildfires prompted timely communication with local resources. Having this information encourages rapid size up and allocation of resource prioritization and efficient assignment of aerial and heavy equipment." And thought that was a good statement that spoke pretty heavily of this. And Drew has continued to provide quite a bit of feedback. This is a notification we sent on February 8th of a hot spot being detected. This signal was very, very weak, and I remember our forecaster had an eagle eye on this particular day and happened to catch this what he indicates as a possible hotspot in southern Logan County real early, and located 3 miles south of Meridian in Logan County, Oklahoma. Drew provides a text message back saying that Logan County fire departments have been notified. They're sending units out to check it. And then several minutes later, after they arrive in the area, he says it's actually a large structure fire, and this stuff is really cool. So that's the kind of feedback we're getting back. We were getting this kind of feedback, every other day through the course of the spring this season as we provided more of them. And there's an actual news article image of the house that was on fire. Now, it did spread. That was a pretty windy day, and it did spread to an adjacent field and burned a couple dozen acres eventually. But it was a structure fire previously unreported that this notification system provided the initial notification for. So that begs the question: just what can you really see via satellite imagery? And if you look at some of the Planck functions, and this diagram here is from Weaver 2004 on some of the theoretical fire sizes that should be possible given different burning temperatures. For legacy, GOES 13, 14, 15, you had 4-kilometer spatial resolution. Say you have a fire about 500K or so, which is actually a little less than what most grassland fires typically burn at, around 590 to 865K. That would render you a minimal fire size of about 70 acres or so that's detectable. Now, I think that's highly dependent on the fire line intensity and the burn temperature of that fire. The hotter you get, the more intense that fire is. Clearly, the more the delta T in that grid box, and the smaller the fire size you're going to detect. In the GOES 16 era, say we have a fire of 500K, that should give you a fire size of about 15 acres or so. And that seems to be pretty in line with a lot of the observations we're seeing, about 10 to 15, maybe 20 acres. But that begs the question, of just how small can you see it? And again, it all comes down to temperature. It turns out that in parts of Oklahoma, we have a lot of oil and natural gas activity out there, and sometimes they burn off excess methane at the top of those oil rigs. So we're talking about a very intense burn over a very small area, probably a square meter or two. And those burn at about 1250 to 1900K. And we're readily seeing those in GOES 16 imagery. We're seeing these flashes out in western Oklahoma, northwestern Oklahoma, again, from the burn off of on the top of oil rigs. Some additional feedback throughout this year, which understand our fire season just effectively ended with some good soaking rains here in the last 1 to 2 weeks. So we've still got a lot of post-season analysis to do. But the text on the left is actually from Oklahoma Emergency Management, forwarded from Forestry. This was received after Tulsa used the notification system for the very first time earlier this year. And they said that the fire notification was the first alert for an event that was previously undispatched, no prior notifications, and likely prevented the development of a large wildfire in Latimer County. There's another text message we got from Pottawatomie County, that hotspot detection was received about 4 minutes prior to dispatch. So again, typically beating local 911 calls by, I'd say, 4 to 5, maybe. I think out in Amarillo's area, they've had some experiences where they're beating them by 12, 15 minutes. You might be wondering about how close are we getting spatially to the location of the fire, and this is an image provided by Oklahoma Forestry of the burn area of one fire, and where our geolocation was. We're off about 1.93 miles in that particular instance. So within 2 miles, which is what you would expect with roughly, legacy 4 kilometer and goes 16 2-kilometer spatial resolution. And this is actually starting to get some press across the Southern Great Plains. You can see this media report came out of the Tulsa market, NWS fighting fires from space. I'm not sure I would totally condone that that headline if they ran that by me first, but they didn't. So, but that's the kind of public response and media response that that this has been getting. And in which case, in that story, for instance, local emergency managers, were highly praising the efforts of the forecasters to let them know where these fires are developing. Probably a lot of questions about the operational workload that this brings into the WFO. We basically staff as if it's a severe weather event. Some of our higher end cases, we've had 2 quote-unquote warning or hotspot forecasters looking for hotspots, interrogating satellite and radar imagery, looking for any sign of a hotspot or a fire out there. And then you pretty much got to dedicate someone, as you should always anyway, to the NDFD process and making sure that that the grids, forecast grids, are precise, because this could directly result in spot forecasts. In fact, the previous iteration of this tool did append a tiny URL that went straight to the hourly weather planner for the fire weather parameters. And we were very proud of that because we were providing weather information before locals even knew they had an incident, really. But I believe the cell carriers, AT&T and Sprint, some update that they provided started losing the ability to append that tiny URL. So that's something we may have to try to work back. But one comment from one of our forecasters saying that I can issue a notification for fire faster than I can issue a severe. So that tells you how efficient the process is. That it's very quick, very efficient. Once you identify the fire, you can issue the notification very quickly. And the guidance that we provided to our forecasters when to issue these, we're basically, again, falling back on the RFTI. We're basing it on the environment. 90% of all wildland fires are pretty benign. But if we have a weather environment that's elevated or greater, we're asking the forecasters to go ahead and send a notification. Also, of course, we don't want to send them for prescribed burns, but we have on occasion, and we're trying to avoid that. If elevated or greater fire weather per the RFTI, not a known prescribed fire, but even on a few prescribed fires, we have found some utility. So we're trying to be aware of abrupt changes that we're seeing in brightness, temperature, or even on the smoke plume via radar of prescribed fire. And if we see some abrupt changes in the fire behavior as far as what we can remotely detect, we're providing that information to Oklahoma Forestry. And it turns out that has caught several escaped prescribed fires through the course of the year. So since the onset of our fire season, which was in mid-January, we've, as of yesterday, I believe, issued 236 notifications so far this year. That's just from WFO Norman. Tulsa may have a very similar number, and Amarillo has at least a few that they've issued as well. So for the state of Oklahoma, you can get an idea of the order of magnitude. It's probably several hundred notifications that have been sent in 2017. So where all is this being used? And I think the most notable thing is once people find out about it, we are getting requests to share the app. And also there are the requests from land management agencies of their local National Weather Service forecast offices to provide this kind of service. The state of Oklahoma is pretty well covered now. Amarillo is also using it in their Texas counties. We have briefed Central Region headquarters, and I believe there are plans for a statewide test across the state of Texas. There's at least been some interest in Denver. and potentially statewide in Colorado, but I'm not 100% sure about that. We had the one request from Puerto Rico, and we've already shared the app with them, and also Wilmington, Marquette, Rapid City, and Billings. And I'm not sure, all these places may not be fully operational in the use of it, but that's at least where we've had requests to share the AWIPS application. So in summary, the tool that we're using provides real-time wildfire notifications. They're generated via cellular text message and transmitted straight out of AWIPS via email to text. And they communicate the geographical location, various site-specific lat and lon, and also site-specific weather information in proximity to remotely sensed wildland fire. I think one of the takeaways here is this is really a deviation from the traditional National Weather Service fire weather role. You know, historically we provided fire weather planning forecasts, spot forecasts, fire weather watches, saying, you know, on a strategic level that critical fire weather conditions will be possible over a certain geographical area, you know, 3 to 2 to 1 day out, where we usually issue a red flag warning. But this really changes from more of a strategic sense to a tactical sense. And there's other work being done by Greg Murdoch and Chris Guitro, I believe, in Pleasant Hills, working with Greg on this too, about looking at interrogating radar imagery in the vicinity of wildland fire and trying to determine if there is tactical information, especially with the proliferation of dual pole imagery that can be used and communicated to firefighters on the front line about changes in fire behavior. I think we're really only at the tip of the iceberg as far as what is possible with GO 16. I know we have several derived products that haven't come out of the beta testing yet about fire line power, radiative power. There's probably a lot more that we can derive from GO 16 than the traditional legacy GOs. And also, I think it does raise some questions about is this kind of a prelude to some sort of future warning paradigm? I mean, essentially what we are providing is a fire-specific warning once a fire has been detected. And I know Heath and Robin at the national level, the fire program, have made presentations about maybe the future of the red flag warning program going to a paradigm similar to that, where red flag warnings are issued once fire is remotely detected. And that certainly seems feasible. Not only with what we're doing here in Oklahoma and in the Southern Plains, but also with as GO 16 becomes operational. So that's all I have, Larry. That concludes my presentation, but I'd be glad to take any questions. I also have here in the room with me Aaron Anderson, who developed the app. If you have any technical questions about how it's developed, how it works, and one of our forecasters, Jonathan Kurtz, is in as well, so he could provide the forecast perspective if needed.
Great. Thanks, Todd. And we do have a question from Patrick Gilchrist in Glasgow asking, have you used Google Earth Link with the messaging?
No, we have not done anything with Google Earth linked to it, but that's an interesting thought.
Are you there? Yep, I'm here. And participants, those of you that entered your audio link number, you guys are unmuted, so you guys can get on the phone here and ask any questions that you may have.
Yeah, this is Ken. I got a question. In the fall, we have they burn the sugarcane fields. Now, will this be showing up? Will this be showing up on satellite for your satellite images? Then
I think that's dependent on a number of things. It very well might. Certainly, with the use of GO 16, those type of burns might show up. I think it would have a lot to do with how intense those fires become. With legacy GOs in the past, I think it, like the plot showed earlier, about 70 acres or so on average before you start to see something. So you were talking a significant fire. I think now with GO 16, we'll likely see much less significant fires, so it's certainly possible. Here in the Southern Plains, there's quite a bit of burning in the Flint Hills, some of those become fairly large burns, but they're prescribed, and that shows up pretty readily. But we do not seem to see all prescribed fire on satellite or on radar. I think your more benign, lower end wildland fire that's prescribed usually does not show up. It's usually the more intense burns.
One other question: how do you handle flaring of the plants due to the gas processes?
Well, the first time we saw it, it happened to be on a pretty high-end fire day, although it occurred around mid-morning before you would really expect the diurnal burn period to kick in. But we were on guard that day anyway, so we did send a notification for it that day, and then, you know, another scan comes in and it's gone. But we did quickly confirm within a matter of an hour or so that from the local emergency manager that it was a flare on top of an oil rig. So now that we know that we're actually seeing that, that was pretty unheard of before, you know, we started seeing the beta test images from GO 16. So now that we know, we're just a little more patient, and we know the approximate counties where we're going to see that type of signal. So yes, we're no longer sending notifications for those now that we're aware of them.
Okay.
Hi, this is Brian Henry at NIPSI. I was wondering, you spoke a little bit about the evolution of the red flag warning possibly down the road. Could you speak a little bit more on that as maybe the shift in focus that you're talking about?
Yeah, Brian, I'm not sure I'm the person to fully address that, but I can certainly provide, I guess, my perspective on it. We've had some success here in the Southern Plains providing, you know, of course we always provide the traditional fire weather watches and red flag warnings, but we also have had some success with some strategic type experimental probabilistic outlooks to help in pre-staging and you know, allocation of resources a few days in advance through the state forestry in Oklahoma and also in Texas. And I think where this becomes really powerful is where you marry those two concepts with the strategic probabilistic forecast for problematic fire, and then you have those resources pre-staged, and then you tactically route them to new developing fires with a warning or a notification like what we're providing here.
Okay.
And Todd, this is Larry. I can expand on that. Brian, of course, being on the fire weather subcommittee, this is also an effort we're pushing not only through the fire weather subcommittee, but also of NWCG, but also through the weather services. You know, getting word back from these investigations and feedback from the field of possibly over-warning or our warning messages kind of getting drowned out by the fact that they're issued so often, and taking a look at how we issue warnings, which is very similar and it hasn't changed in over 30 or 40 years. And now you have the advent of dual pole radar and GO 16 and all sorts of tools coming online. And I think it's high time we started taking a look at our red flag warning program as a fire community and really deciding whether the way we're doing things really addresses where we need to be with that. And I can certainly present at a future Fire on the Fives a little bit of what we've come up with the Fire Weather Subcommittee. And we're just in the beginning stages. This is certainly not something that's going to be dropped on people next year. This is you know, a 5 to 10 year plan on where, you know, where we want to go with this program.
Okay, gotcha. Thanks.
This is Tom in Glasgow. Going back to the Google Earth concept, would that be a big step to play around with that and see if we can do something with that? And then you mentioned also, Todd, about the somebody's working with radar detection and signatures. If you can expound on that a little bit more.
Sure, Tom. Yeah, I'm going to let Aaron Anderson, our ITO, tackle the question about Google Earth. As far as radar signatures, Greg Murdoch and I met down in Midland, Texas. He and I authored a paper on on radar interrogation of the Bastrop fire in Central Texas back in 2011, and he's continuing that today with with the advent of dual pole, and I think he's just getting that off the ground, but early results are somewhat promising, so that's something to keep an eye on in the future. But I'll let Aaron address the question about Google Earth.
Yeah, it's definitely something that's possible. One thing that's, because like Todd said, we have gone through a couple of iterations of the app, and one of the things that I kind of included trying to think ahead to the future was make it so, you know, offices would have a little bit of kind of configurability and to be able to do things, you know, without having to, you know, necessarily code up, you know, their own thing. Like one of the things it does now is you can designate your own kind of post-process script where, you know, it'll give you a JSON file that has all the data, all the context, you know, all the stuff you entered in, and then you can tell it, okay, I want you to run this script on it. So you could write a script that generates, you know, a Google Earth file or a KML or, you know, anything like that. So I've tried to leave it open-ended so people can do things that's going to meet their needs and the needs of their partners. Does that kind of answer your question?
Yeah, sounds good. Thank you.
And Larry, this is Todd again. I had a quick comment of our forecaster, Jonathan Kurtz, commented after, I can't remember who it was, Ken, I believe, that asked a question about the flaring on the oil rigs. And Jonathan correctly pointed out that now that we know they're there, the brightness temperature of those are immediately very high. So that's a distinguishing factor that can help us discriminate those from a fire.
Well, the good news is smokestacks don't move too quickly, so should be able to just tell from your lat lawn that automatically ought to trigger a check this twice before issuing kind of thing.
Absolutely. Like I said, now that we know they're there, we kind of know what to look for.
Yeah. Marty Whitmore, it looks like you had a question.
Hey, this is Ryan in Missoula. Marty's just the one that signed in. I was just curious if they'd put this up on the SCP yet so that we could download it and kind of look at it and play with it, or?
Yeah, right now it is. It's on the VLab. It hasn't been made public yet. We've been kind of adding in some offices here and there as kind of a beta test. Because like I said, we've been going through some iterations and getting some feedback to try to make this, you know, as robust as possible for folks. So we haven't opened it up, you know, weather service wide yet, but it's steadily getting out to more and more. But there
What's the name of that project?
The code is hosted, and there's wiki and then kind of a usage guide and installation instructions, things like that.
What's the name of the project on VLab?
Hotspot notification tool.
Okay, thank you.
Yeah, you might not be able to see it because I don't think it's publicly visible yet.
This is Patrick. Can I ask one more quick question?
Yeah, go ahead.
I just had a quick question on the flares. Now, we border the Bakken, and again, were these flares that you were seeing, were they just one-time ignitions when they were drilling, or are these like the consistent flares associated with oil wells that are standing when they're burning off the natural gas?
This is where they're burning off the natural gas. These are standing oil rigs, and they were burning off the excess natural gas.
Okay, so it's the same thing we'd be seeing.
We believe, to the best of our knowledge.
Thank you.
You bet.
Hey, Todd, it's Dan.
Oh, sorry, Dan, before we get to you, looks like Mark Lofelbein had a question.
Oh, it just looks like you're kind of duplicating some of the features of INWS with the dissemination of the text messages. Have you looked into creating a formal product that could be used and INWS would hopefully pick it up and distribute it for you?
I have had that thought, and I think that would be a perfect way to go. But yeah, that's something I think I need to figure out who the best person to talk to about that and how to kind of get that integrated. Because you're right, it's really something that, you know, that could keep offices from having to maintain contact lists and adding them into the application. You know, the emergency managers can go and select where they want it from, and then we just issue from there.
I think your contact would be
mapped. I had that thought.
I think Matt Davis would be your contact. He is the admin for INWS and IRIS.
Okay. All right. I'll get in contact with them and see if this is something, that we could do that, because I agree. I think that's the perfect route to go with it.
Okay. Looks like Herb Arnold has a question.
Can you hear me, Larry?
We can.
Oh, okay, thanks. I was fiddling with my mute here. So since we're talking about detection of stuff that's really not classical weather phenomena, does this have to stay? I mean, thinking about expanding it to a broader, nationwide kind of capability, would this have to stay under NWS sort of operational control? Is this something that would that could fall, more among the operational type spice, the weather and intelligence types for interagency firefighting?
Well, Todd, I can, I guess, answer it from a weather service standpoint. I think, there is an issue of seeing it on the go satellites, and we've probably got the equipment to best see that information the fastest. But I would certainly think that this would be something that should be interagency and be a partnership. If this is to be expanded and improved upon, I think certainly at some point feedback from the fire agencies and deciding where we go from here would certainly be something that would be something that could be discussed.
It just seems like a great tool that could only get easier to use, and it almost would seem likely that's going to slip out of control of strictly weather related intelligence.
Yeah, Larry, I'll follow up on that too. I think just like you said, I've noticed over the course of the last 2 years, our forecasters gaining expertise in interrogating satellite and radar data and identifying these, much like you do severe thunderstorms or convection. And the question has been asked, can it be automated? And sure, you could build some algorithm that looks for some change in temperature, but to be honest, especially with GOES 16, you see some bizarre things that you can't really identify quickly, and some burns are much lower intensity, some are much hotter, and you see flickering. And you actually, just like in issuing severe convective warnings, you hear forecasters say, well, I'm going to wait one more scan and see if that picks up, and sometimes you'll hit some threshold where it saturates the pixel, and they've been looking at it all along, and they're like, oh, I should have known 10 minutes ago that was a fire, So it's very interesting how you see this expertise develop. And I think if you did an algorithm, and I know it's not directly what the question was related to, but it was a thought that crossed my mind. If you did an algorithm, it'd be very analogous to doing like an algorithm for tornadic vortex signature in the 88D. It might catch some, it might provide a lot of false alarms, but I think at least right now, my impression is you really need that forecaster expertise and remote sensing to kind of detect these. But also, we have the pulse of a lot of our local fire agencies, certainly here in Oklahoma with Oklahoma Forestry and Texas A&M Forest Service, and it just, right now, it was just a service gap that we found that we could fill.
Thanks, Todd.
Thanks. Dan Borson.
Yeah, my question is, Todd, how much time have you guys had to invest in putting in a situational awareness stuff to your forecast, of known spot forecast, known existing fires that the agencies have already responded to, or are you still sending out the alerts on those things? Or is that mostly what you get from the ODEM display that you mentioned that's at the state capitol?
Yeah, Dan, that's mostly coming from the ODEM. They're logging these, of course, and for a brief while this season, I was actually getting end of the day summaries of that was like a verification summary on a map, graphically showing where we provided notifications and then and where they actually had reported fires, and that's something we can go back and generate for the remainder of the season on demand. But no, mostly the forecasters have that ODEM watch officer map up while they're issuing these notifications, and they can see which ones have already been hit with notifications and which ones haven't. And Aaron is actually working to implement an AWIPS map also, where you can see it directly over the IR imagery.
Yeah, I've been doing some work to try and get these ingested into AWIPS so they're displayable just like other products.
Thanks, Todd.
You bet, Dan.
Any other questions for Todd? We're coming up on just about an hour into the webinar, so one last call for questions. Okay, with that, I want to thank Todd and the fine folks there at Norman for putting on this webinar, and thanks for attending. Interesting information, and certainly if you have more questions, you can get a hold of Todd directly. And again, this session was recorded. I will try and get it to a spot where everybody can take a look at it, both what NOAA and Weather Service as well as non-NOAA as well, and I'll get word out to that. Thanks again for attending this month's Fire on the Fives. We've kind of started in fits and starts, but I think we got a decent plan going forward to make sure that we've got speakers for most of the months for Fire on the Fives. In fact, we're trying to get Mark Finney from the Missoula lab, Fire Lab, to hopefully he'll be on the May Fire on the Fives, and he'll be talking about his fire spread modeling. So stay tuned for more information on that, Fire on the Fives. And with that, again, thank you very much for attending, and have a great day.
Thanks, Larry.